Good morning, everyone. Welcome to today's video. In today's video, we are going to be looking at heat of formation. Now, heat of formation, the topic of heat of formation is similar to calculating the delta H with bond energies, except for now we're using these values called heats of formation. Standard enthalpy or heat of formation is a measure of the energy released or consumed when 1 mole of a substance is created under the standard conditions from its pure elements. So we're looking at values that are going to be given to us similar to what we did in bond energy, except for now these values are different. These don't represent the energy within the bonds. These represent the energy that it took to create the entire molecule. Now notice, to calculate delta H, when we're doing bond energy, we are doing break minus make, or reactants minus products. Now for heat of formation, we're doing products minus the reactants. So we're flip-flopping things. This is something important that you're going to want to remember. So think Puerto Rico, PR, products minus reactants. This is the opposite way than bond energy. So I want to make sure I'm getting that clear. I also linked the standard heats of formation for various molecules. All the molecules that you're going to need, everything you're going to need is going to be in this chart. So we're going to use the standard heats of formation that are found on this chart here, more so on this top part. We're not going to deal too much with ions in this unit. So here you can see we've got all these compounds. We've got a delta H in kilojoules per mole. Some of these are positive, some of these are negative. So we're going to be using this as a reference as we complete this homework. So let's go through and do an example problem here. So I'm going to pull this up. Let me go ahead and share my screen. Zoom. All right, here we are. So here is today's worksheet. I just got to make sure that I have the standard enthalpies open. All right. So for this first example, we're given 2NO plus O2 to produce 2NO2. Now, I'm going to write this again over to the side, products minus reactants. We need to remember that this is products minus the reactants. That way, we get the right answer. So this first equation we have on the reactants, we have 2 NO2s. So I have 2 NO2s. Now it's NO2 gas, so I'm going to look at my standard heats of formation chart. And we will see that the standard heat of formation for NO2, hopefully you're looking with me, it's in alphabetical order. NO2 gas is positive 33.9. Positive 33.9. I put the positive in there because we know we're dealing with negatives and positives, and I just want to make sure I'm not losing track. So that's my only product, so that's what I'm going to be putting in square brackets. Then I'm going to subtract the sum of the reactants. So again, we have 2 NOs, so I'm going to put the 2 there because I need to multiply that by 2, and NO gas has a value of positive 90.4. And then I'm going to find O2. Let's look for O2. Doesn't look like O2's on there, does it? That's interesting. Well, let's think about what O2 is. O2 is a pure substance. So a pure substance is found in nature. It doesn't take any energy to produce. It doesn't take any energy to for it to be a thing. It just exists. So anytime you come across hydrogen, oxygen, any of those big 7, chlorine, fluorine, nitrogen, any of those, you're going to leave that as 0. Because it doesn't take any heat to form a natural substance. It doesn't take any energy to form a natural substance. It just occurs. Okay? So now we have our values. I have 2 times 33.9. That is, I'm just going to write it below to help organize, 67.8. And then I have 2 times 90.4. Notice how these are positive values. 180.9. So then I'm going to take 67.8, subtract 180.9. And my delta H comes out to be negative 113.1 kilojoules. If this is a negative delta H value, I read that as releasing energy. So I've released energy in this reaction. So this reaction would be exothermic. If the reactants, or if the energy is exothermic, or if the product is negative and it's exothermic, that means that we would have 113.1 kilojoules on the product side of the reaction, because we created that energy. If it's released, you're creating it. All right, so heat of formation, products minus reactants, in order to get your answer. Pure substances like oxygen have a value of 1, so you would leave that as 1. It's not going to be on your chart, so you just need to know if it's not on your chart, you leave it as 0. And once you plug in those values, it's pretty straightforward math. Okay, so I went through that first example with you. Hopefully that makes pretty good sense. The only thing here is I do not want you mistaking bond energy and heat of formation. The two are different, and we have different processes for those. Okay, hope you find that video pretty easy and pretty simple. Email me if you would like to see a key to check your work, and I hope to see you guys soon. I love you guys. I really miss you. Hope you guys are enjoying whatever time you have to have at home. Find your happiness. Keep riding with it. All right, I'll catch you guys next time. Peace.